Today we're going to talk about simplifying rational expressions. As we talked about yesterday, the textbook definition of rational is anything that can be written in the form a over b, where b cannot equal 0. So basically just a fancy word for anything that can be written as a fraction. So if we want to simplify rational expressions, basically we're just simplifying fractions, just like you did back in elementary school when you had to simplify 4 over 6. Then both of those were divisible by 2, and you simplified that to be 2/3. We're going to use that same idea, but now there are going to be variables involved. The important thing to remember that's going to come into play all throughout this unit is we have monomials and we have polynomials. Remember, monomials do not have addition and subtraction in them. That's just things multiplied together. For example, 5x cubed y. Polynomials have addition and subtraction involved. Example, x squared plus 5. Monomials, you can look at each piece individually. You're free to cancel. So these are free to cancel. Polynomials, these things are stuck together. You can only cancel this with something on the bottom if that whole thing is on the bottom exactly the same. So that's going to be really important throughout this whole unit, because when you get desperate, you're going to try to cancel things that aren't allowed. So let's do an example. We'll start with monomials. You've done problems exactly like this before. So again, like I said before, monomials can be done piece by piece, so you can cancel individual things. So we reduce 12 over 16, just like we would a normal fraction. So those are both divisible by 4. So when you divide 12 by 4, you get 3. When you divide 16 by 4, you get 4. Then we reduce our x's using our exponent rules that we learned in the last unit. So if we have 3 x's on the top and 1 on the bottom, 3 minus 1 is 2. So we have x squared in the numerator. Then we have to do the same with our y's. Y cubed over y to the 5th. That would leave us with y squared in the denominator. So this is our simplified expression. But as we talked about yesterday, we have to do our restrictions. What can't our variables be? Because the denominator can't equal 0. Well, the 16, that's not going to give us a 0. We don't have to worry about that. But if x was 0, 16 times 0 times whatever y is would give us 0. So that's bad. So x cannot equal 0. Same thing if y was 0. 0 to the 5th would be 0. 16 times whatever times 0 would still be 0. So y can also not equal 0. So the simplified version is this, and then these are your restrictions. Notice I did the restrictions on what it was before I canceled. You can't do the restrictions from here, because then we'd be missing our x's. Okay, now let's go on to a polynomial. So we'll start with one that's relatively straightforward. So again, you can't break this into pieces. That's a no-no. So canceling these two, nice try, but not allowed. Reducing the 12 and the 4, nice try, not allowed. You can only cancel if the whole thing can cancel with the bottom. So you might think, well, there's nothing there that we can cancel. But what you can do instead is factor. So we factor our top, our numerator, into x plus 4 and x plus 3. Two numbers that multiply to give me 12, add to give me 7, 4 and 3. The denominator, there's no back term there, but notice we have a GCF of x. Told you factoring was going to come back to haunt you. So you pull out the x and you get x plus 4. Now, these two pieces right here are exactly the same. So those could cancel. However, before we do that, we want to do our restrictions, because you have to do your restrictions before you cancel. So our restrictions in this case would be x can't equal 0, because if x was 0, 0 times whatever is in this parenthesis is going to give you 0. The other restriction is x can't equal -4, because if we put -4 here, -4 plus 4 is 0, 0 times negative 4, still 0. So these are my restrictions. X cannot equal 0, X cannot equal negative 4. Then I do my simplifying. My X plus 4's cancel, leaving me with X plus 3 over X. Some of you might be tempted, oh look, I have those X's there, but this is a polynomial. You can't cancel part of a polynomial. So if you need to, leave that in parentheses so that you know you cannot touch that unless there's something exactly on the bottom like it. So this would be our simplified version, and then these are our restrictions. Okay, one last example. Same idea, but some of you are going to freak out because there are X's and Y's. So first thing to notice, these are not monomials. These are polynomials. So we can't just cancel X's and Y's. That's a no-go. So we have to factor this. This numerator, hopefully you recognize by now, that's the difference of cubes. That's where we make the small parenthesis in the front, X minus Y, and then we make the larger parenthesis in the back, X squared, change the sign, multiply those two together, and then square the back term. And again, this never factors. Do not try it. It looks so tempting. It does not. Leave it alone. Then we go down and do our denominator. Well, this has a GCF of X, but notice when I pull that X out, I get X squared minus Y squared. That's the difference of squares. You need to keep factoring. X plus Y, X minus Y. Do your restrictions now, and these are a little more tricky. This one's easy. By now we should know this one. X cannot equal 0. Here, what would make this parenthesis equal to 0? Well, if these two were the same. I'm sorry, if this was the opposite of this one. So X cannot equal negative Y. Sometimes you'll see people write this one as well, but basically these two are the same. They're just, the negative one is on the opposite side. And then from this one, X can't equal Y. Because if X and Y were the same, when you subtract them, you would get 0. So here are our restrictions. And then we just need to do our canceling. So the X minus Y's cancel. And then we're finished. Again, this guy's free to cancel, but there's no one up here that's free to cancel with him. This could cancel, but this doesn't factor, so I'm not going to get one of those. So I'm finished. So my final answer, X squared plus XY plus Y squared over X plus Y. Could you multiply these two back together? Sure, but that's just another place to make a silly mistake and lose points. So I don't, I just leave them there. And that's all there is to simplifying rational expressions. Make sure you do your quick checks to see if you can do some of these by yourself.